Welcome to the 2022 question B3. The image on the right shows a Microsoft Surface Pro. It consists of a touchscreen and kickstand. So here's our touchscreen and there's our little kickstand. Figure B3 here shows the plan and elevation of the touchscreen ABC. So I've simplified it down to just a plain ABCD and similar Surface Pro. Draw the given plan and elevation of the touchscreen ABC. So you can see height there is 160 and 120. The scale first of all is 1:2. So every measurement there we're essentially going to divide it by 2. So that's no longer 60, it's 30, 30, 70, 120, 30, 30. Okay. So just to give this enough space, I'll come down 150, plenty of space there for my XY line, and I'm going to begin drawing my plan and elevation. So like it says, down 70 to A, so A is going to be somewhere at that level, and I'm just going to pick a point here and draw vertically up there. That's the corresponding point A. Alright, from A we're going an angle of 35 degrees, that's parallel to it, so an angle of 35 degrees down. And that's going to be 120 long. Using my sliding set squares, I'm going to draw this plane. Today, so okay, and they're telling us that it's 1660, which is vertical. So 30, 30, and slide this square again to get my edge there. So that's my plane A, B, C, and D, and FG runs the middle of that. Actually, I'll leave that because I haven't asked it to do anything with it yet. So I project up and find the elevation. Heights they've given me for my elevation, like I said, is 1660, which is 30 and 30 really. So just mark the height of 30 because I'll use that later. 60. And that is C to B. So A, B, C, D. Let's draw those edges in. So that's the elevation and plan completed. Now determine the horizontal and vertical traces of the oblique plane that contains touchscreen A, B, C, D. Okay, so they're telling us that this contains, the oblique plane contains this surface, so we can see that the horizontal trace is going to be where that touches the ground. Okay, and we're going to use that then to find our vertical trace. So horizontal trace is going to be exactly there. We just need to project or draw it in and show that continuing up to find where it hits the elevation and where it hits the XY line. So that's my HT. Alright, and now we need to find the elevation of that, so I'm going to take a horizontal cut. So a horizontal cut essentially is going to run parallel to our HT. It will be horizontal up here. So we need to find that point where it hits the vertical trace. So project that parallel to HT. Okay, and this already is parallel. BC is already parallel to AD, so we can just send it forward where it hits our vertical trace right here. Project that up. And it's a horizontal line, so extend across. So here is our BT. So that's our traces there of plane or oblique plane ABCD. Now the bezel or the black frame, so this black frame of the touchscreen is offset by 16 millimeters from each edge. Okay, so 16 millimeters, we have to divide that by 2, so that's 8 millimeters from each edge. Draw the plan and elevation of the bezel. Okay, so in order to do that, we need to find a true shape of that touchscreen or plane ABCD. So first we need to find it as an edge view so that we can find it as a true shape or look perpendicular to it. Okay, there's a couple of different ways of finding the true shape of it, but we'll start with getting the edge view. So line AD, okay, is a true length line, same with BC. So if we actually look out along that line, so looking out here, okay, we'll get a point view of AD, and if we have a point view of a line that's contained on a plane, we get an edge view of that plane. So we'll take an auxiliary up here, perpendicular to AD. Just extend these out to begin with. Okay, so perpendicular, AD is perpendicular to it, so I'm just going to use that. Okay, so this is our x1, y1. Okay, we're creating an auxiliary that's projected from a plane, so it's an auxiliary elevation, so heights come from my elevation. AD is on the xy line, so that's AD, and BC, get the height of BC, which we know from drawing it earlier is 60, but I'll just take the height, follow it up. Just extend that on. So this is an edge view. Okay, so that's an edge view of that plane. Okay, now a couple of ways we can find a true shape. Like I said, we could look out perpendicular to it, so x1, x2, y2, okay, and take our distances 2 steps back. right? But we are going to use rubber battlement. So I'll just slide this up so we can see the full screen, and I actually get a new page just to stick down here. So I just stuck another piece of paper underneath this. In an exam you'll have an A2 sheet, so you'll have no issue with keeping everything contained on one page. So let's rotate AD. So just extend on my horizon line, or horizontal plane. So I'm going to rotate this down so it's resting on the horizontal plane, projected down, so that it's essentially rotated from this position, so rotated from that angle position down, sitting flat on the horizontal plane. So you see, and project that down. And bring out the widths. So that rectangle there is the true shape of that surface, okay, because we've got the true length here, if we're looking down on top of AD, so that's the true length. We found the true length in the auxiliary of line BC or AB and CD, found it there, so we now have the true length there. In the question, they said the bezel, so distance from there to there, or there to there, okay, is 16 mil, so we divide that by 2, that's 8. So I'm measuring a distance of 8 millimeters here on all the sides, 8 on this side as well. So let's just draw that in. Right, so that's our bezel running around the outside, and we want to show it in the plan and elevation. So I'm going to project these back and around and down, and the width there I can actually extend straight up. So let's I can go straight back. Right, I'm going to project these depths. Take them back. the projections back to plan. Now we'll locate these lines up here, so just call this, I'll actually index all of these just so we can follow them around. 2, 3, 4, so that's brought around, that's 1, 2, 3, 4. So coming down then here, got 4, 1, 2, 3. Alright, so I'm going to project them up, maybe somewhere along those lines, along those projection lines. Now, what we know from our principles of graphics is that parallel lines are parallel in all views, and we can see that here. Right? We've got this line here, which is actually, I'll just index it, it's B, and that's C. So AB is parallel to 1, 4. Okay, and they're parallel in this view, and you can see they're parallel here in this view. So they're going to be parallel up here in elevation as well. And likewise, CD and 2, 3 are parallel. Actually, all 4 of these lines are parallel. So, using that knowledge, okay, I'm going to use a reference line. So I'm just going to use this here as a reference line. I'll use another reference line here, which we can use to complete this. Right, so the other reference line, I'm going to find that in elevation. That's where it hits the base. Okay, and I know it's going to be parallel to BC, because it's parallel to BC, or AB, sorry, in plan. So, slide and set squares. Parallel, that is my reference line. And the reference line, I should have brought up, save me some time, but let's do it now. Parallel, BC also, RAB. Okay, and point 1 is contained on that yellow one, so here's point 1. Point 4 is also contained on it. Point 2 is on the pink one, brought up here. 2, and point 3 there also. And they're also parallel in this direction, so it should be horizontal. And then just heavy in those edges. Okay, so it's kind of the almost part of that question. And on to part C then. We're telling us that the line FG, so the line FG here, in plan and elevation shows the hinge position of the kickstand. So that's the kickstand. So it's essentially this here is FG. So you had X-ray vision, so we've got a kickstand running back along there. The angle between the kickstand and a horizontal plane is 35 degrees when in the open position. So the angle between the kickstand and the horizontal plane is 35 degrees. So this is our ground here, our horizontal plane. So the angle there between those is 35 degrees. So just to show there, 35 degrees is the angle there, the true angle of inclination between them. Draw the plan and elevation of the open kickstand. Determine and indicate the true angle between the touchscreen ABCD and the kickstand. So they're looking for a true angle between those two. Right. So I'm going to start with drawing in my FG, which I didn't draw at the start, just to kind of keep my drawing clear. FG. pages after moving slightly. Okay, so I measured up the height earlier on. I've got that marker there for me. So F, G, and I have that down here also. Okay, so that's F and G. Which are actually going to be parallel to AB, said, or BC, parallel in all views. F, G. Right, and we want to see that angle of 35 degrees, okay, with that hinge. So I'm going to find a point view of FG, and I can do that by projecting up into my auxiliary. So sliding set squares once again. So that's a point view of FG. Okay. So they're telling us that's we have a point view of it now. The angle between the kickstand and the horizontal plane is 35 degrees in the open position. Okay, so our kickstand will be here at a 35 degree angle. Okay, from FG to our horizontal plane. Okay, because we're getting an edge view. Because we have a point view of FG, that gives us an edge view of that entire kickstand. So I'm going to measure an angle here of 35 degrees just so we can use it for our solution. So anywhere really out here, I'm going to measure just the mark 35 degrees. So that is a 35 degree angle. I'm going to use sliding set squares then to draw from there back. Okay, so that is the position of my kickstand. Okay, and they want us to find the plan and elevation of the open kickstand. So this is representing 2 points on our kickstands, the back point here and the further back point. So I'm just going to call this, PQ. Alright, and they're going to be in line with our edges here. So again, I'm going to set them back at that same angle to our elevation, or to our plan from our auxiliary. That is going to be point PQ. I can finish them off by joining up to F and to G. Save that 35 degree angle. And they are resting on the ground. They are on the horizontal plane. Okay? Right, on the X1, Y1. So there's an auxiliary elevation, they'll be on the XY in our elevation here. I'm joining to G, Q to G, P to F, so hidden detail. And that'll be horizontal edge. So P and Q there. Right, so that's part 1 done. Determine and indicate the true angle between the touchscreen ABC and the kickstand. So here's our edge view of the kickstand or the touchscreen. Here's our edge view of the kickstand. So let's indicate angle here, which is exactly 100 degrees. So I'm going to indicate there 100 degrees. 22 hours. That is B3 completed.